This is a consolidation lesson that brings together all of the work you've done from the product rule and the quotient rule. It also makes use of the chain rule as well to differentiate a real variety of different functions. Now, these are important skills for you to master, so that's why we're going to have another lesson on it. Just looking at a few more complicated examples, and then at the end of this lesson, what you will be undertaking for your work is the final homework assignment for the Year 12 work. Okay, let's remind ourselves of the product rule and the quotient rules. Okay, so the product rule enables us to differentiate the product of two functions. So that's two things times together, and the quotient rule enables us to differentiate the quotient, or two things divided by each other. Okay, I'll go the wrong way round, but never mind. There we go. So let's bring them up there. So the product rule, remember, this is not given to you. So for this one here, the product rule, okay, you need to learn this. But it's not too difficult to learn, really, because you just have two separate functions, and the product rule is write down one of the functions, differentiate the other one. There's a plus in the middle, so order doesn't matter. And then you swap round and write the other one down and differentiate that one. Now, this quotient rule is in your formula book, okay, on page 6. So just make sure you're aware of where it is. Remember, in the formula book version, it talks about differentiating f of x over g of x, I think it is. I tend to remember it in terms of u's and v's like this, but if you want to do your working as f over g, again, that's absolutely fine. And what you've been doing up until now, hopefully with all of the questions you've been doing, is you've been writing out what u is, you've been writing out what v is, you've been differentiating them, you've been quoting the formula or the rule that you're using, and then you've been subbing in just to avoid mistakes. Okay, so all we've got today is 4 different examples, okay, that we're going to have a look at together. So here's our first example. So if you'd like to write down that example, so it just says find the value of dy dx. I could have said find the gradient at that point on the curve with that equation. So you can see that's a quotient. So we're going to make use of the quotient rule. So remember, u is the thing that's on the top. So that's x plus 3. So my du dx, when I differentiate that, I'm going to get 1. V is the thing on the bottom. So we've got 2x plus 1 to the power half. So typically within product and quotient rules, they often make use of the chain rule. This is a chain rule, remember. So this is what you're thinking of as your u for your chain rule. Hopefully you're getting really quite good at doing these just by writing them down like this. So I bring down the power. Remember, it'd be a half u to the minus a half, but the u is just the bracket. Big times sign, okay? So remember, by the chain rule, u must times by du dx, or the derivative of what is in the bracket. The 2 and the half cancel. So what do I end up with? I end up with 2x plus 1 to the minus a half. Okay, so let's quote our quotient rule. Remember, it always starts with v, so it goes v du dx minus u dv dx all over v squared. Let's plug in our things that we've got at the top here, so we can see nice and clearly what they are. V du dx, that's going to be 2x plus 1 to the half. Do remember you get the minus there, minus u dv dx, so u is x plus 3, dv dx is 2x plus 1 to the minus a half, all over v squared. Remember, v is your denominator. When I square that, I get 2x plus 1. Now, if you remember these, this was the kind of question that when you're not going on to use the differential to evaluate something, that I said you would need to actually simplify this, because remember, this 2x plus 1 to the minus a half is effectively 1 over the root of 2x plus 1. So we've got a fraction within a fraction. But in a question like this, all they're asking you for is the value of the gradient at this point. Okay, so at that point, that is when x equals 12. So all I'm going to do is, I'm not going to waste my time simplifying it. I'm just going to use this. Okay, so show subbing in. Okay, a bit like you're applying the limits mark. So replacing your x with 12. Okay, takes you a moment to do. Okay, like that. And then, to be perfectly honest, just put it in your calculator like that. Type it in really carefully. Okay, luckily these 2 times 12 plus 1 is 25, root 25 is 5. So we're going to get some nice numbers there. Pop it in your calculator. You have shown all of the working you need to show, all right, here. So as long as you've written this down, you can type that very carefully into your calculator and you'll get all the marks for that. So notice that I think this question, really important point to make, don't bother simplifying this if you're just going to sub values into it. You don't need to. Okay, right, next example then, here we go. So this is 4 marks worth of a question. So we're differentiating y equals x to the 4 over cos 3x. So another quotient rule. U is the numerator. That's not difficult to differentiate. Bring down the power, reduce the power by 1. V is the denominator. Be careful with this. The first thing you've got to remember is what cos differentiates to. Cos goes to minus sign. It's always of the same argument, so 3x, 3x. But remember, by making use of the chain rule, this would be your u. You times by du dx, so we get the 3 at the beginning. Okay, don't forget the 3, don't forget the minus. Right, let's quote our quotient rule again. dy dx is v du dx minus u dv dx all over v squared. Okay, so v du dx, normally write that bit at the beginning, so 4x cubed cos 3x, v du dx minus u dv dx, we've got an extra minus there, so that becomes a plus 3x to the 4 sine 3x, all over v squared, and I can write that as cos squared 3x. I can just write a little squared there. Now, to be honest, that would be fine if they were asking you to simplify it. Okay, I might take a factor of x cubed out the top. Okay, I'd certainly do that if I was going to be solving that or anything, but to be perfectly honest, what you've got, unless they ask it for it in any particular way, to be perfectly honest, that answer there would be perfectly fine. Okay, with that one. Right, another one. So I'm going too fast, just pause. All right. Slightly different question here. All right, not really chain rule, product rule, but it's just about the equation of normal, because I think we do need a bit of practice with those. We sometimes misread the questions and don't give it in the right answer. So I've just thrown one of those in. Okay, so this is our function y. Find the equation of the normal. You know, soon as you see equation of tangent, equation of normal, you need to differentiate. So let's do our differential. Differentiate that 2e to the x, 2e to the x, 3x squared, bring down the power, reduce the power by 1, plus 2 disappears. Find the equation of the normal to C at the point where the curve intercepts the y-axis. So in a moment, we're going to work out the equation of a normal, so we're going to use that gradient, but I need to find what this point is where the curve intercepts the y-axis. Okay, so intercepts the y-axis, think about what's going on there. X is 0, isn't it, when you intercept the y-axis? So let's find what the y-coordinate is of that. 2e to the 0 plus 3 times 0 plus 2. Okay, so the value is going to be 4. Okay, so the point where it intercepts the y-axis is going to be 0, 4. Okay, now, so what we want to do, we want the equation of the normal at this point. Okay, let's work out the gradient at that point. So at 0, 4, what's my gradient? Remember, this is the gradient of the tangent, isn't it? 2e to the 0 plus 6 times 0. So that's 0. So that's my gradient of my tangent. That's not 0. 6 times 0 is 0, but we've got the plus 2 here, so it's 2. So the gradient of my normal then, if the gradient of the tangent is 2, gradient of the normal minus a half. Okay, so the equation of the normal, okay, at that point 0, 4 is, you can either use y minus y1 equals m times x minus x1, or you can use y equals mx plus c, because this, remember, is your y-intercept. So y equals m x plus c. Okay, so that there is the equation of my normal. So the only thing I want to do now, let's go and look at my question. Let's make sure I'm not going to throw any marks away. Oh, they don't want it in that form, they want it in that form. So do make sure you write it in that form. So I'll times by 2 first. Okay, to get rid of my fractions, 2y equals minus x plus 8. They want it all on one side equals 0. So x plus 2y minus 8 equals 0. Do always, before you move on from a question, before you underline your final answer, do make sure, okay, that you check, has the question asked for it in a particular form. A, B, C are integers to be found. Okay, let's state them then. A is 1, B is 2, C is minus 8. Just belt and braces for that one. Okay, one last question then. This is a good question, this one. 10 marker, so this will probably be a question quite near the end of the paper. Okay, so curve has that equation, find the differential of it. All right, I'm going to need a bit of room, so I'm just going to do some of my working for my, what rule are we using here? That's right, product rule. So u is equal to, doesn't matter which way round, that, so what's du dx? So you write it down, 3x squared minus 2. V is equal to e to the minus x. Be really careful with this. What is dv dx? You know e to the something goes to e to the something, but remember, by the chain rule, you get the minus at the beginning because you differentiate the minus x to get the minus 1. Lovely. Okay, so I'm going to use f dash x. Remember what it is. It's u dv dx plus v du dx. It's the product rule, so it's the more simple one of those. So let's have a look at what we get there. U dv dx, so I'm going to write that at the beginning, times that. Okay, plus v du dx. Do make sure that you pop a bracket around it. V du dx. Okay, and then, to be honest, that's perfectly fine, but I notice everything has got a factor of e to the minus x, so let's take out my e to the minus x out the front, and what do I get? I get 3x squared minus 2 from my second bracket. Be careful, this has got a minus at the beginning, so I get minus x cubed and then plus 2x, okay? So just be careful with that. That's fine for my answer. So that's your part A. Part B. Now let's read this one carefully, 6 marks. The normal to C at the origin intersects the curve again at P. Okay, and we're looking at where the intersection happens. So we want the normal to the curve at the origin. Okay, so we can find the equation of that, then we can find where that intersects this curve. Okay, so a bit of simultaneous equations there. So we want the normal at the origin. So to find the equation of the normal at the origin, we're going to need to know what the gradient is at the origin. So seeing as it's function notation, let's do f dash of 0. So that's saying what's my gradient when x is 0. Put it in carefully. Some bits do become 0, but some bits don't. So we get e to the 0, 3 times 0, minus 2, minus 0, plus 2 times 0. So really carefully pick out the bits that we've got left there. E to 0 is 1, okay, and we've got a minus 2. So that gives us minus 2. So remember, this is the gradient of the tangent. So my gradient, you see, you've got to really keep track of what you're doing to make sure you've got a purpose as to where you're heading, but you remember where you've got so far. What's the gradient of my normal? That's right, a half. Okay, so what's my equation of my normal then? Because it goes through the origin, okay, it will just have the equation y equals mx. It's got gradient a half, so y equals a half x. Okay, so now the question is talking about where does this intersect my original curve? So where they intersect, we've got two functions. This is the same as y equals. We've got a y equals function here and a y equals function here. So let's put them equal to each other. Where they intersect, that y is equal to that y. Okay. Now the question isn't asking us to solve that. It's just saying show that it satisfies that equation. So all we've really got left to do is to take the equation that we've got here and make it look like that. Okay, so let's times through by 2 and let's times out that bracket that's on the right. So remember, I've times by 2 as well. So I get 2x cubed e to the minus x minus, remember I've times by 2, 4x e to the minus x. Okay, right, now can you see my answer here, okay, has got an e to the plus x in it, not an e to the minus x in it. So let's times through then by e to the x, okay, because these e to the minus x's are like fractions. So all I'm doing now really is I'm manipulating it to look like the thing I'm trying to show that. Now the thing you'll notice here is we've got a few too many x's here. Okay, now reason being that this normal intersects the curve. It says again at P. So it will intersect once at the origin, because normals will intersect the curve there. It will intersect once at the origin, and then it will intersect again at P. And that's the point we're interested in. So the solution we're not interested in is 0 for x. So x isn't equal to 0. So that means then we can take this and we can divide through by 0, okay? Because this here is my solution, okay, to where it already intersects the curve at the origin, because it's a normal there. We're pretty much there really. Can you see the thing we're trying to prove? All they've done is written it as 2x squared equals e to the x plus 4. Job done. So that's quite a big marker of a question there. Okay, there's sort of a bit of coordinate geometry really going on, which you did a long time ago. So yes, we're differentiating more complicated things. We're using the product rule. But other than that, what we're doing, we're finding gradients of normals, equations of normals, and then we're finding where it intersects the curve. So that takes you way back to your coordinate geometry stuff that you did quite a long way back in year 12. So you've got to remember all of these techniques, okay? If you're not sure about any of those, please just rewind the video, work through the examples again, make sure you're happy with them, and please make sure you've got them all written down in your notes, okay? Right, it's over to you. So no questions from the book this time, it's just going to be the homework assignment. It is quite a big homework assignment, it's worth 60 marks, okay? Lots of questions, lots to do. So work through it slowly and steadily, checking all your answers carefully, make sure you give your answers in the form they ask for, make sure you're using any range of values that they're asking for, and make sure you're giving them what they want. Okay, show all your working like I've been showing for your chain, for your product rule and your quotient rule, and do it nice and carefully, and check each of your answers, because you don't have the answers in the back of the book. Check each of your answers really carefully before you move on. Okay, and those are going to be submitted on Teams, please. I'll just have a look at what the date is. So that's going to be next week. So for these, so submit, there'll be a homework assignment set up, and for my group it will be submitting on Teams it'll be Thursday 25th of June. Okay, that's for my lot, but anyway, you'll see the homework assignment set up. Okay, so good luck with that then. As I said, do replay anything you're not sure about. Thank you very much.